Dear friends, welcome to Infos. Welcome to another video, Infos. Here also, we have to see industrial electrical engineering. Here, we are going to see two important components in electrical or electronics. They are called active and passive components. So, here we can see what do you mean by active component, what do you mean by passive component, what are the major difference between them, then what is the role and application of these components in our industry. So basically the active components require an external power source to operate and can amplify or control the signals. And what about the passive components? They do not require an external power source and can store, dissipate or consume energy. In various industries, active components bring control and intelligence while passive components maintain stability. So, in the coming slides, we can see how they are functioning. Then we can see the comparison, basic comparison between active as well as passive elements. Then these active elements require an external power source to function. Then in the case of passive elements, they use energy from the circuit, storing or dissipating the energy. Then active elements can generate, control and amplify the signal or the power and provide power gain. Then what about the passive elements? They store or maintain energy in the form of voltage or current. There is no amplification here that declines the signal or the power. Examples of active elements are diode, ICs, transistors, that is semiconductors, etc. Then in the case of passive elements, they are resistors, capacitors, inductors and transformers. Then we can see what is the role of active and passive components in our industry. Here are some examples I have shown in the figure. The active elements such as transistors and power ICs use external power to amplify and switch signals, making them crucial for functions such as motor control, power conversion, and signal processing. This motor control, that is also a vast area, then we will come across. Passive elements such as resistors, capacitors, inductors, transformer, etc. are used to store and dissipate energy for filtering, energy storage and regulating the voltage. Then we can see what are the applications. First one, active components. These active components are used in PLCs and microcontrollers mainly. They are used in industrial automation for controlling the machinery and the processes. Here in this figure also we can see control center, then for the cellular communication, etc. These are using. Then sensors. Sensors means that detect and measure physical changes in an environment and convert them into electrical signals. Usually they are converting into electrical signals for automation systems and control systems. Since these electrical signals are very easy to manipulate, then control, and we can read that also very simple manner. Then this proximity, photoelectric and temperature sensor, only these three I have mentioned here. That is why proximity sensor means that it detects the presence or absence of nearby object without physical contact. Then photoelectric, that is light. Then temperature sensor, it detects the temperature and it will convert, definitely it will convert to electrical signal, easy to amplify, conversion, manipulation, etc. That is why. Then we can see what are the main applications. So some of the applications of active components, motor control, it will come across. Diodes and rectifiers. Then diodes, they convert rectifiers, alternating power from the grid into AC to DC, direct current needed for many electronic and control circuits. Then these active components, that is diodes, rectifiers, etc. using. are using. Then motor control. Transistors are used to switch and regulate current, enabling precise control of motor speed, optimize the use of energy, and ensure safety by controlling the starting, stopping, and protection. So these active components, they have a major role to play in the control. Then application of passive components. Here, the figure step up and step down voltage, that is transformers from the generating stations, how it is converted, that is using stepping up and step down transformers. Energy storage and dissipation. Resistors, capacitors, and inductors store and dissipate energy, performing essential functions like filtering and controlling the current flow. Then what about the transformers? Then in the area of power distribution, the transformers, a type of passive components, are used to step up or step down voltages for safe and efficient power distribution across an industrial facility. So here in the case of AC, most of the industries, they use AC, then transformer plays a major role. Then voltage and current regulation. Passive components such as capacitors or inductors help to smooth out voltage and current fluctuations, ensuring stable power delivery. We can see how these one of the passive components, these capacitor, then the inductors, how they will smoothen out signals. In the next presentation, we can see that also. Then more applications on passive components. As a filter, then frequency selection and filtering. Inductors and capacitors form resonance circuits that select specific frequencies or filter out unwanted signals known as the noises in high frequency industrial applications. So here an electromagnetic interference filter. Then how when the input is signal plus the noise, that is the unwanted signal, then this filter that will filter out our input signal and gives a faithful output signal that is shown in the figure. Then noise elimination and suppression. An isolation transformer eliminates electrical noise by providing a clean, stable power supply through galvanic isolation. Just I am explaining galvanic isolation in the next sentence, which creates a barrier between the input and output circuits via electromagnetic induction rather than a direct electrical connection. We know, we will see in a transformer how they are magnetically coupled, not electrically coupled. That we will come when we are dealing with the another vast area that is used in most of the industries transformers. We will come. Then this in the case of noise filtering, as far as this passive components are concerned, here the transformer's design can suppress both common mode noise and differential mode noise. Common mode noise means noise to ground. Here you can see in the primary and secondary, there is ground connection is there, then phase and neutral is there. So noise to ground, that is the common mode noise they can eliminate. Then what about the differential mode noise? That is noise between the phase and neutral. That also it can eliminate. So for noise filtering, these are used. Here you can see the shield as well as. So these shields also provide this smoothing out our signals by eliminating the noise. Some transformers use electrostatic shields to further enhance this noise reduction. So it is also shown in the figure. These shields act as a grounded conductive barrier that blocks high frequency noise from transferring between windings. So we have seen some of the applications of active as well as passive components in industry. So what is the significance? The passive components provide the foundational support that use or store energy. So in the circuit, we can use the passive components to store or consume energy. Active components are the brains that can provide power gain for signal amplification, switching, and overall system control. So, for the control, these active components had a major role that we have seen. So, the synergetic functioning of active and passive components create sophisticated industrial application. Then they are coming shoulder to shoulder. They give a very good result in the case of industrial applications. Active and passive components together form the fundamental building blocks of complex systems, ensuring stable and efficient operation by both delivering power and shaping electrical signal. So we have seen one will amplify the signal and another one declines. Then what about the energy sources, etc. we have seen. So the session covered the fundamental electrical concepts, active and passive components, and its industrial applications. The understanding of the facts will lead to the effective management and troubleshooting of electrical circuits working with industrial systems. Thank you. Thank you for the patient listening. Please join our Telegram channel if not yet. So for various updates you can have from this one. Thank you so much and a great day. Thank you.